Hello, and thanks for joining today's webinar. We'll be starting here in about 3 minutes. Thanks. Hello, and thanks for joining today's webinar. We'll be starting here in about 2 minutes or so. Thanks. Hello, and welcome to the VEST webinar series. I'm Frank Newsom, your moderator for today's webinar session. And today we are broadcasting live from IFPE 2023, where we'll be introducing new game-changing features just released within NetBlok3D. This session is scheduled to last 30 minutes and is being recorded. You'll be able to submit questions or comments at any time by posting in the questions section located within your webinar control panel. Questions may be answered as they're posted, or we will try to address them in the last portion of the webinar. You may also choose to submit your question in the survey issued at the conclusion of today's webinar. Now, it's my pleasure to introduce our speaker for today's webinar session, Carlo Malone. Carlo has worked in the hydraulics industry for many years and currently manages application sales and training for VEST desktop and cloud products. Carlo?
Thank you, Frank. Thank you all attendees for joining today's webinar. So yesterday we did a small schematic in the NetSkeme, and like I explained today, I'm going to start from there. So let me get back to where we left yesterday. Design that block that has been described with a schematic on yesterday demonstration. So like I said yesterday, NetSkeme is a software in the cloud. You don't need to install anything. You just find symbols, data sheet, you create part list and so on. Everything done in a DWG format. So I'm now going to download the DWG file from the schematic. Because I need for today's demonstration just one command that is not yet enabled in NetSkeme, and for that I will use HyDraw CAD. But this is the schematic I have drawn yesterday, and today we'll try to design this small high-low block and see all the features for NetBlok3D. NetBlok3D is like NetSkeme, a full cloud-based application. You will be able to sign in with your username and password, and you enter in the design canvas. The target here is application engineers or sales engineers that need to quickly sketch a 3D layout of a manifold to share with their customer. It's not meant to complete the design fully, but we will see that we have a lot of interesting feature here. So a NetBlok, let me expand it to full screen, is coming with a huge library of cavities, and if you are familiar with MD tools, you will find the same cavity that are present there. So let me just go and find a HyDraw Force or X-Rod C8 C810 3N. So we just place a cavity, and when we place a cavity, we can see an engraving, which we can move the engraving in different location. And the cavity, once selected, will be described with all its port. So this is a 3-way cartridge cavity, and we will be able to define nets. For those that are not familiar with MD tools, we need to understand a bit what a net is. So let me just quickly go to that is an image taken from the schematic. And let me just take a different color. So a net, when we analyze a block, a schematic like this, let me just color. So I'm doing manually with the mouse, so I find it bit. So this is a net. We can call it however we want. So I will call it HP, high pressure. And this net is basically a list of ports that are connected together. So we have item 9, port 2, then we have item HP, and so on. So usually when you don't design starting with information in an XML file, you need to print your diagram, color your lines, and start placing together the components. What is important to understand is that when we design, if we help with color coded, then we have our life much easier. And in order to apply this color coded in NetBlok, we will be able just to select and specify for every port in an entity what is the net name. But today I'm going to start easily and I show you a much smoother workflow. Like I said, this command that I'm using is not yet in NetSkeme. So I will use HyDraw, and I'm opening HyDraw. And we understand why HyDraw in this case is interesting. But like I said, we have this technology already embedded in some cloud technology using the same engine as NetSkeme. So now my drawing is being loaded. So the two commands that I'm going to use now is net. So I tried to sketch the net earlier in that whiteboard. So for us, the net is what I had tried to sketch. So this will be for me my HP, high pressure net. This will be my T2 net. That will be my low pressure net. That will be my T1. Let me call this net as pilot. You are not forced to rename nets. What I find very handy designing manifold, and I frequently do design manifolds, is giving a name to a net because it helps me really finding in the design process more convenient access to all the cavities. So in HyDraw, we can generate a net, and you should expect at a certain point in the development to have the same approach in NetSkeme. Now we can export to MD Tools this schematic. So I'm not saying that you cannot design this block without HyDraw XML, and it is doable, but we see how easy it is when we have an XML made ready to the design. So I'll call it high low power unit, and that is my schematic. Now I can delete this part of my design. I will be able to load the schematic directly in the NetBlok browser. So I'm loading the schematic file, which will be this XML file that I have just generated. Once the schematic is loaded, NetBlok will do a verification of data. There is no error here, but in case you specify a wrong cavity or a cavity that is missing in your block, you will be able to assign a correct cavity during this process. Cavity insertion can be really done by selecting the components, and you can click insert and place the component. Similarly, you can also double click, and that will be the same. And so let me just place all the components. Changing face is as easy as dragging. So you can see that it is very, very, very handy and intuitive. Let me place all the items. And we can rotate the view just by using the right mouse click, while the left mouse click is for pen and also for cavity selection. Helping with colors, we can try to guess how our position will be. So let me just move this cavity. You can type in dimensions. So let me put at 55, 65. And we can also stretch this here. We can use connect command. Let me just get rid of some of these cavities. We have a connect command allows us to do connection between cavities. So I want to connect these two together. We can specify position, precise position, 55 and 75, so that at the end our drawing will be much simpler. Like I showed earlier, it is possible to move engravings in different positions. And let me start placing some of these items. So I assume to have the pump coming from the right. So I have the HP, so the high pressure port. And it is also possible to place component from the net, which is why I really like to define the net names and specify and find so then net names and colors. So low pressure, I place my low pressure here. From the HP, I'll miss the U port. So as you see, there is a green tick box, tick mark, showing that that cavity is already placed. So let me place the U. This is a huge port. MU, maybe we put the MU on the front face. And I can do the stretch drill. So I can reduce this drill on my block. I can move my cavity somewhere here. And again, I need to specify precise position for the cavity so that the machine drawing will be good. Similarly, I can drag this cavity. And as you see, when you get close, automatically NetBlok will try to align cavities. So in this case, the vertical position is aligned to the U port, and I can specify a 30 millimeter on X. Looks good. I just stretch my drill here. NetBlok has been presented somewhere last year in a webinar. We are adding new features, and I show you some of them. So one of the main problem I was finding is that it was not possible to add the 3D models of the components. So now this is a relief valve from my diagram, and I will be able to add a new 3D model, selecting from a library of predefined 3D model. I need a relief valve, and I'll take maybe yes, this is good, skew adjusting relief valve. This is just a placeholder. It's not you will see then in the drawings that we will see a 3D model, but for us this is really just a placeholder. If it is not needed, we can just hide it. And with this command, hide components, it will be possible to hide all components directly in the block. So similarly, I'll do a new component here for my logic element that was in HyDraw force. I'll take a screw. No, not adjustable. Let me take a fixed. Well, that's fine. That's the same. That's not really important. So that's my. And of course, if you just drag the cavity in a different position, the 3D model will just follow. By using undo Control Z, you will be able to yes, undo the previous operation. So looks good. I can compact a bit more my block. I can add, this was a sequencing valve, so let me add a new sequencing valve. And this sequencing valve will be always a screw type sequencing valve. So we can see a preview of the 3D model, and we can just click OK. And now that cavity will be that 3D model will show up next to the cavity. NetBlok allows us to add and remove material. So by looking at my block, I can compact a bit. I want to do a connect my cavity with the port number 2. I can stretch my drill. So I make this kind of connection. I want to align this cavity with the HP, and this drill maybe I shorten. Anytime during the design, we can request a design check. So in this case, I can do a design check, and clearly a lot of things are missing. We have broken nets only, no other issues. I can introduce some design errors, like here we have overlapping thread with the working port. So the design check will now list as that there is a working area intersect with that area of HP. So this is not meant to do a complete check of your design. We always recommend them to go to MD Tools, but it will help finding common errors done during this initial design process. I want to stretch this drill a bit more. So stretch drill, you just take the cavity and you stretch the drill. Let me go on with my design. I expand the T2 and place my port. And please, if you have questions, feel free to post. I'm going to connect my T2 port. So connect T2 with port number 2, and automatically you get the position and the diameter correct. I want to change on the Y direction, so we can use these small icons to specify a position. Let me put 75 millimeters, so that's good. Of course, in our design, well, let me put also the T1 port, which is missing, and this one will fit, connect directly to the relief valve. This looks too close, so let me add some material, stretch block, touch the face, and just add a few material. And this looks good. There is no design without construction port. So in order to place a construction port, we will just go to the library and let me add expander plugs. I'll take just a small one, MB600. So in this case, those are just pilot lines to the sequencing valve. So just a recommendation when you design blocks, try to make the shortest path possible for drills that bring oil flow. Signal really can have a lot of construction plugs, but whenever possible, try to make a direct connection. This will optimize the efficiency of your design. I just place my plug here. Well, let me change phase to it, and I want to connect my plug with port number I want to connect my plug with port number 2. And maybe I can just stretch my drill a bit. Yes, there is an intersection. To make a better intersection, I can sink a bit this cavity. So you can select a cavity and sink it by typing a different spot phase step. Let me put 4 mm. And in this case, I will just need to move my cavity. Or I can just do connect again. And I'll do another construction port for the green connection, connecting this with port number 3, and I'll take another construction port and place on this face. So again, I can do connect my drill with port number 3. So the block looks good. In this case, I want to add an orifice plug. So this is a sequencing valve. It's a pilot line. Sometimes you put orifice plug to prevent some vibration in the system. So I will add an orifice plug. This is a new command recently added to NetBlok. So we can add an orifice plug to a cavity, and we can select the size. It is possible also to insert valves like those insert check valves. I'm just come to my mind have Parker, right? Also some insert valves, HIDAC as well, Booker. Let me take just an orifice in this case, and that's my orifice, ORF. This will be also engraved in the block. And you can define the net. So in this case, I'm connecting the same net. So basically I'm saying they belong to the same net, but that's basically, those are basically two different nets. I can compact a bit my block, so I see that I have room on the right face, and I can just stretch my face here. And let me just place a couple of mounting holes. So I go to my bolt holes metric. I take M8, and that will be my first mounting hole. And I take another one, that's my second mounting holes. And of course, we can define position, precise position. So 100 by 90, and this one will be maybe 10 by 10. This connection is at risk. We can measure distance, so we can display wall thickness between cavities. So we can select the two cavities, and this will show the minimum distance between cavities. So I'd like to change a bit. Let me move slightly to the left my LP. So let's make it 72 millimeter, and that looks better. So like I shown, display wall thickness is very handy because it helps you with measuring on the fly and isolating distance between cavities. So this block looks good, but there may be situations where you have more critical situations. Another command to verify what you are doing is the display machining sequence. So if you need to check which cavity is used. So yesterday I didn't do a good component selection. So this is a very large port. This cavity looks small compared to the size. So by using machining information, I can define that's an FC10S2, and in case you need, you can just select another cavity, a different cavity from there. And let me do that. I'll place a HYDAC, larger size. Let me take FC12-2. That will be my check valve, and I put it here. So I leave the engraving check so that when I share with my colleagues, they will just give a look if this component selection is done. So in this case, I act like a sales engineer that may be not having too much experience with component selection, and in this case, I'm just willing to ask someone to verify if I did a good component selection. You really don't need to be that precise. The purpose here is to share a document with your customer. And of course, you can go into many more details, but let's assume that the block looks good for us. Let me add well, the port here, it's a low pressure, and let me add a 3D model so that at the end our block will look better. That's a check valve. And again, if you have questions, just feel free to write in the chat. So this is our block, which looks good, and I'm going to save. I'll use again this block. That's my webinar to high-low manifold. And I'll use this block as a starting point for my webinar 2 days from now, speaking about more integration between the NetBlok and our other software that we have. So again, you save, and the file format is an MBXML file format. For those using MD tools, you should be familiar with this file format. And basically, it's an XML file with all the geometric information of the block. In this case, we also store information of the 3D model, and I'll show you in a minute. So for now, I'm just going to create my manifold layout drawing. I click OK. And now this a machine, an online server will process this, and I will get an email within a few minutes with all the machining drawing. In the meantime, you can do whatever you want. You can design a new block. So let me start a new block, and you can start placing cavities. And again, stretching. When you open a file, you will get asked what if you want to save your design, and I don't want to save my design. If I open again that block, that MBXML file will contain not only the geometry of the block, but also the 3D model. And I can go on and do a design change, hide the 3D models, do a design check. In this case, I expect an issue in the design check, which is the broken net HP, And there are also that intersection between component 1 with port 1 of component 12, and maybe that's just, yes, those are just minor issues, but of course, like I said, it's you should give some design check, but don't expect it to be complete. This is really a way to quickly start designing a block and share with your customer. Then there is time to refine all your design, but your customer may then need ask you move this cavity on the front face because of different connections. So the importance is really the ease of doing change. Because we expect to have many interaction with our customer in order to get to the final solution. So our task here is to provide a tool that is easy, does not require the CAD skills, does not require too many powerful workstation. So here at the show we have a Chromebook that can run very efficiently NetBlok. So really the target is to have a way to interact and design a block that will be then ready to do more refinement. Let me check my email if the drawing has arrived. Yes, the answer yes. So let me open that email and I bring to the main screen. So you will get an email, a drawing for design new manifold, and that's my zip file. So in the email, you will get the MBXML file so that you can use for importing into MD2s or opening again in a NetBlok. And this zip package contains, let me get back to it, contains a DWG file. Let me extract it and put into the webinar. So this PDF file is basically the 2D layout of my manifold drawing. So it shows construction plugs, all the dimensions of my block, the position of mounting holes, engraving and position of ports, the 3D model of the components. On the top left, we will see the port list. And on the right, you will see the projection type. So that at least people, so this is using third angle projection. So for those from Europe, this may conflict with your standard. But I know some customers in Europe that use this type of projection. The same file, PDF, if you need to do some change, maybe attach the diagram, can be then open in HyDraw, or I show you that it will be possible to open also in NetSkeme. So I can go to NetSkeme, open, I don't save it, and browse, and I can open my new manifold. So like I said yesterday, NetSkeme is a DWG editor, a light DWG editor. It has not full compatibility with all AutoCAD entities, but most AutoCAD files will open fine. So for instance, here I could just draw a diagram. And the one question could be, is it possible to import that schematic that I made yesterday? Unfortunately, not yet, but it's on our pipeline. So the ability to copy and paste the items from different diagrams open in the same. A technique could be to really create a symbol of that diagram and then import it like I showed yesterday with a reservoir. Of course, if you have AutoCAD, you can open in AutoCAD. If you have HyDraw, you will be able to open in HyDraw, and there it will be much easier to save. The third file that is generated is a step file. Let me just bring up Inventor. I should have done it. I should have opened earlier, but hopefully it's not taking long to open. So this is a step file containing the geometry. So if you need to integrate your manifold assembly, give to your customer because he has to see the how it overlaps with other components in the system, then you can just send the step file. So let me just drag this on my inventor. And now it should be loading. So when opening a CAD system, you will just follow the rules of that CAD system. And so this will be my open file. And if we can look also at the internal file. For now, we are not creating a shrink curve up model. For those using MD tools, shrink curve up is a simplified version of the file. So here we really generate the same geometry as has been designed, because the intent is to share with the design engineers to check the interaction with the machine. I don't see any question. We have just 2 minutes left, so if you have any, feel free to post now. Otherwise, I turn it over to Frank, and I thank you again for attending today's webinar.
Alrighty, thank you, Carlo. We hope that everybody found this to be a compelling webinar showing the very latest and powerful features just introduced in NetBlok3D. If you've not already done so, we urge you to navigate to netblok3d.com to request a free trial evaluation. Tomorrow, you'll receive an email containing a link to view a replay of today's session. Feel free to share this link with your colleagues. A link to view video segments from prior webinars will also be provided in that email. As you can see, we also do have the webinar posted on various social media channels. We invite you to follow these channels so that you can receive the latest updates on our upcoming webinars. Our next webinar is scheduled to occur tomorrow, Thursday, March 16th, where interoperability between our online circuit design application NetSkeme Hydraulic and other VEST circuit design platforms, including HyDraw CAD, will be showcased. Thanks again, Carlo, and thanks to everybody for attending. Have a pleasant and safe day.